How are you? Can everyone hear me, by the way? I have a really soft voice, so sometimes it can be low. Okay. So recently, I've been looking into programming microcontrollers, playing with Raspberry Pis and microcontroller simulators, not to build anything important, of course, but just to entertain my curiosity. Now, as I was playing in this low-level programming space, something in me was not happy. So I was coding in C, and the more I looked at the code I was writing, the more unhappy I was about the fact that this code that I was writing was not so easy to read and it was way too verbose. And just to give you an idea of what I was going through, microcontrollers have this really cool module called an analog to digital converter. And what this module does is that it reads a voltage strength from a pin and it reports it back to you as a digital value between zero and some maximum. And so to get this value to, say, millivolts, you will do some multiplications to it, and you'll get your millivolts. But in my situation, I had an array of ADC values. That's what they call. And I had to convert each and every one of these values to millivolts. And this is what the code looked like. So what you have is a for loop, and all that we're doing, we're saying we have an array of ADC samples, and for every sample value in that array, we're doing some multiplications to it, or multiplication and division, and writing it to the other array. So basically, we're just mapping the first array to the second array. Now, being someone who is used to writing JavaScript, these for loops really bothered me. Because in JavaScript, the same code will look something like this. Just one line of code compared to 3 lines of a for loop. And so to find a solution to this niggle of mine, I went on a quest. I was going to find a programming language that I can use to program low-level microcontroller modules, but with the same modern concepts I've come to enjoy from Brandon's favorite language, JavaScript. And so I did find some options, but as I was exploring my options, I was still not happy. The language I needed had to be able to transpile to C so that it does not limit me as to which microcontroller I get to use. And so this requirement alone already eliminated really great options like Rust, Swift, and Golang. And so the only real option I was left with was Nimlang. Now, Nim is basically like Python. What that means is that to represent code blocks, it uses tabs. And that's why I did not like it. No offense to the Python people. I find the Python syntax less appealing. And it's a bit awkward for me to write. So there I was, back to square one, trying to find this programming language until this one quiet night, inspired by lo-fi bits and a flash of inspiration, I thought, why not build the tool I want myself? So we want something, but the tools that we have do not allow us to have the thing we want. So why not build the tool we want ourselves? One that will allow us to write the code we want to write the way we want to write it. And so that's what I'm going to show you today. In just 3 steps, I will show you how to build your own programming language, one that is inspired by the way that you want to write code. My name is Batandwa, and I'm a software engineer at a company called BBD Software. I also happen to have studied computer science at the University of Cape Town with a strong focus on using technology to solve problems that we as humans face. Now, this drive to solve problems that are worth solving really played a role in how I wanted the program experience to be like from a programming language. Which brings us to the first step in building any piece of software, really, design. So yes, we're building a programming language, but the question then is, what will it look like? What will its syntax be like? As I was working through this design, I pulled inspiration from one of my favorite languages also, well, as you might know, JavaScript. Now, the thing about JavaScript is that it is a deeply inconsistent, historically messy, intuitively designed, hilariously and irredeemably broken language. JavaScript is so broken that people write entire frameworks just to avoid writing JavaScript. And they still go ahead to use JavaScript to do the same thing. But of all the things that have been famously said about JavaScript, this has to be one of my favorite ones, by a guy called Douglas, who happens to be one of the guys who actually developed JavaScript. He said, JavaScript is the only language that he's aware of that people don't feel the need to learn before they start using it. And if you think about it, he's right. There's quite a few of us here, sitting here today, who seriously had to sit down and learn JavaScript before we could start building useful things with it. This, in my view, is because the JavaScript syntax is straightforward. And because the language has less features, there are less things to learn before one can become productive with it. Now, this is important. As someone who has used languages like C++, I've come to appreciate the simplicity of the JavaScript syntax. In JavaScript, if you want a function, you're going to say you want a function. Like literally, you're going to use the function keyword. If you want a variable, you're going to say you want a variable. If you want to define this thing called f of x, you're going to define this thing called f of x. There is something about this syntax that just clicks without requiring too much brain power. Again, as someone who has used languages like C and C++ and has seen what Rust looks like, this is a syntax that makes me want to write code. But now, it would rather be naive of me to say the syntax is the only thing that makes JavaScript great. The other thing that makes JavaScript work so well for me is this idea of first-class functions. Now, language with first-class functions allows you to treat functions as data. Functions can be passed as arguments, they can be returned from other functions, and they can be assigned to variables like any other data type. This idea of first-class functions works hand in hand with the idea of higher-order functions, which are basically functions that accept other functions as their arguments. So these two concepts really mean a lot to me, because with just these two concepts, we can implement declarative programming constructs using just functions. For example, going back to the example that I had earlier, where I had to map one array to an array of something else, I could use a for loop, like I was doing in C. Or I could just use one line. If you look at line number 10 there, just one line to say we have an array of numbers, and then for every value in that array of numbers, we want to map it to something else and write the results to another array. So yes, I like JavaScript because it has a great syntax, but it also allows for declarative programming through higher order and first-class functions. Okay, we're still designing. I'm not going to bore you with the details of all of this stuff, but we're still designing. So as I was working through or continuing to work with this design, I pulled inspiration from another language called Dart. Now, Dart is described as an approachable, portable, and productive programming language, especially for user application development. That's why they use it in Flutter. Dart has this really cool concept called extension methods. And what this means basically is that you can define methods on a data type outside of where the data type is defined. For example, if we have an int, if you look at line number 2, if we have an int, we can say the int dot some method. In this case, we're saying the int dot square, but the int is not an object, but we're treating it like an object. This is cool because with this approach, or with extension methods, we can make primitive types blend nicely with types we have defined in the standard library. If you look at, say, for example, C again. C has this data type called char. And a char array is supposed to represent a string. But the string that is stored in a char array is an ASCII string. What that means then, each character is 8 bits or 1 byte. But as we've come to learn, ASCII is not enough to represent all the languages that we have in the world, or to represent characters from all the languages that we have in the world. That's why then we have encodings like UTF, UTF-16, etc. So what languages do, they will define their own string class on top of what the language comes with, which is the char array. And this string class will allow us then to represent more encodings with UTF or UTF-16. And so now, if you have a char array and a string class, how do you make them, and they're both supposed to be strings, how do you make the transition or the conversion of a char array to a string class? One way, which I've come to like, is to use an extension method. That is, on a char array, we can define an extension method called toLibraryString. If you look at line number 7 there, and what that extension method does is that if you call it on a char array, It's going to take the char array and it's going to create a string instance out of it. This is cool. And so I like extension methods because, like I said, they make it easy for us to blend primitive types nicely with types we have defined in the standard library. Now, bringing all this together, the lessons from JavaScript and the lessons from Dart, we have a programming language that looks like this. If you want to define a variable or declare a variable, you're going to say my variable or my variable name, give it a type or just give it a value. That's all up to you. If you want to define an array, you're going to define an array. In this case, I'm using square brackets. I like square brackets. In C, you will use curly braces. I find that weird, but that's another conversation. If you're going to define a function, you're going to say you want a function, just like in JavaScript. And going back, to this idea of first-class functions, you can define an anonymous function, and that anonymous function, you can store it in a variable. In this case, we're saying we have an anonymous function that takes a nothing. If you look at the right-hand side of the equal sign, it takes a nothing, and it returns an int64. But this anonymous function, we're assigning it to a variable called my function, which means then my function, since it's a variable, we can treat it like any other variable. But what's cool about my function is that we can call it because, well, it is a function. So now we can store functions and variables. What if we want to pass functions to other functions? Now, we're talking about higher order functions. So in this case, we have, if you look at the screen here, we have run all, which is a function. And this run all function takes an array of callables. And what it's doing with an array of callables, if you look at line number 5, it's calling each function in that array of callables. So there was another problem to solve here, because now if you're saying we have a function that takes in other functions, how do we tell the compiler what those other functions look like? So I took this idea from Dart, where we use type defs or type definitions. And what you're saying here, we're saying to the compiler that there is a function that takes a nothing. If you look at line number 1, it takes a nothing and it returns nothing. And that function, a function that looks like that is called a callable, which means then by line number 3, we can say run all takes in an array of callables, and the transpiler will know what a callable is. So that's cool. So that are those functions. Now we have to look at more complicated data types, like structs. This is how you define a struct. Nothing fancy. So here we have a person. Struct person has a name and a surname. And to instantiate an instance of a person, you're going to say var person. If we look at line number 7 there, you're going to say var person is equal to person. Now, some of you are going to argue why I don't have the new keyword. This is just a preference. I don't. If I'm instantiating a person, why do I still need to specify new when I know that I'm instantiating a person? So that's why I chose not to add new. But again, this was a preference. Okay, so now we can define structs and we can instantiate structs. So how do we add methods to a struct? So given the fact that I'm already building for extension methods, I thought for now, just to get things to work, and when I say the way to add methods to a struct is through extension methods. So in this case, if we have a person struct, we can define an extension method on a struct, for example, called full name. It returns a string. And all that it does, if we look at line number 8 there, it takes the name concatenated with the surname, and it returns that. So that's how you would add a method. And then obviously by line number 15, you're able to call that method. Cool. So that was the first step, designing the programming language. The next step is probably the hardest one, because now we have to write code, and that is building the transpiler. So my transpiler has 4 phases. We have lexical analysis. We have the parsing phase, which will take the tokens that are produced by lexical analysis and build what we call an AST. So that's the parser. And now we're then going to have semantics analysis, which is going to take the AST from the parser and produce what we call an annotated AST. We say it's annotated because we have details that we have added to this AST that the parser could not pick up from the original source code. The semantics analysis phase will also do something really cool. It checks if the program makes sense. For example, is your if statement in the right place? Are you assigning a value to a variable that is compatible with the type of that variable? Or are you passing arguments to a function that the function expects? So that's semantics analysis. The next phase is code generation, where we take this annotated AST and we produce C code. Remember I said our programming language needs to be able to transpile to C. This code generator phase basically does that. That's where it produces C, or that's where we produce C. Cool. Going into detail, as already mentioned, we have the lexical analysis phase. And all that we're doing in this phase, we're taking the source file and we produce a stream of tokens out of the source file. Now, it is these tokens that are meaningful to our programming language, and they're going to be the building blocks that the parser is going to use to make sense of what the program structure is like. Now, what you have on the screen is an example of, okay, look at line number 1 only. You have a program that just declares a variable, of type int. So the lexical analysis phase, what it will do when it sees that is going to say, okay, cool. There's a lot of characters here. Well, I don't know how many characters, but it's going to say the first set of characters matches the var keyword. The my var is going to be identified as an identifier because, well, it is an identifier. The colon will be identified as CO. And then the int, well, at this phase, we don't know if it's a data type or not. So we're going to identify it as an identifier. And then obviously, we have an SC at the end. That's a semicolon. So that's what the lexical analysis is going to give us. So from a source file, we get a stream of tokens. Now, back in the 20th century, we're now in the 21st century, people will write lexers from scratch. Or really smart people who write lexers from scratch. Today, however, we are rather blessed because we have all these really cool tools that makes this job of writing a lexer a lot easier for us. Now, as someone who is comfortable in Java, I chose Entler. Entler is a powerful language recognition tool that can be used to build parsers. So to solve my lexical analysis problem, I wrote an Entler G4 file, that's what they called. And this file tells Entler to generate a lexer in Java that can pass some text into a stream of tokens as defined in the grammar file. And what you're seeing on the screen is an example of such a file. Actually, it's part of the pinlang lexer grammar file. And how this file works, you have, if you look at line number 3 there, you have a token called SC, or a token ID called SC, and then it's followed by a colon. And on the right-hand side of the colon, you have the characters that the token should match. So SC is going to match all semicolons. That's line number 3. And if you look at import, which is line number 19, the import underscore ID is going to match all import keywords. Okay. So that's cool. I will share a link at the end of the talk to this file. So if it doesn't make sense now, you can actually play with it when you get home. So now we have solved for the problem of producing tokens out of a source file. The next thing we have to solve for is building the grammar of the language. So in the pinlang project, this is called parsing. That is, given a stream of tokens, how do we build a representation? One that is like a tree structure that represents the language constructs being represented by the tokens. This is where you would identify things like if statements, for example, while loops, do while loops, variable declarations, function calls, etc. So another really cool way to think of parsing vs lexing is that in lexical analysis, you identify the words and punctuation that make up your programming language. Whereas in parsing, you take these words and punctuation and you recognize the kind of sentences being created. That's one way to think about it. So Entler also allows us to define parser rules. And what you're seeing on the screen here is another file that I wrote called parser or script parser. It's supposed to be pinlang parser. This is an old screenshot, my bad. But what you're seeing here is what a parser rule file looks like. So what we have is, if you look at line number 12 there, we're defining a language import rule. And what we're telling Entler is that the language import rule is made up of the lexical analysis rules, which are import path, and SC. So a language import rule is going to start with an import path. Sorry, it's going to start with an import or the import keyword. It's going to be followed by the import path, and it's going to be followed by a semicolon. So import some path, semicolon. But what I want to show you is another rule called expression. And what we're saying here is that an expression is made up of, or an expression can be a function call expression, can be like a type pass expression, can be, if you look at line number 9, it can be a multiplication expression. Line number 12, an addition expression. What we're giving Entler are alternatives, which means that any ordering of tokens that match any of these alternatives is going to be identified as an expression. But what I want to point out here is that the order of these alternatives really matters, because line number 9 is the multiplication expression, right? Line number 12 is the addition expression. What this tells Entler is that multiplication, since it comes before addition, is more important or has higher precedence than addition. So if you have something like 2 times 3 plus 4, for example, Entler will know based on this expression tree or this ordering of alternatives that the 2 times 3 should be evaluated before the plus 4. And then obviously once we have the answer for that, we can add the plus 4. So again, I will share a link to this file, so don't worry if it doesn't make sense when you see it like this. Once you see the bigger file, it will make sense. Cool. Okay, so now we can pass our source files into tokens, and we can transform that stream of tokens into an abstract syntax tree. So now how do we ensure that the program is trying to make sense, or actually what the program is trying to do actually makes sense? This, like I said, is what we call semantics analysis. This is where we check if, like I said before, any statement is in the right place, a variable is assigned its type, or we're passing arguments to a function that the function expects. Now, there are multiple ways to build a semantics analyzer. How I did it is by implementing something called a pipe and filter pattern, where a filter is a semantic rule that is applied on the AST. And because it's a pipe and filter, what's going to happen is that we're going to have rule 1 applied on the AST. Once rule 1 is done, we're going to have rule 2 applied on the AST, then rule 3, then rule 4, and so on and so on. But in some cases, like the expression rule, for example, a rule will recursively call itself. So this is how I chose to do it. There are multiple ways to implement a semantics analyzer, and which one you go with is up to you. Okay, so now we can run semantic checks on the program. Once we can do that, we want to be able to produce the C code, that is code generation. And this is probably one of the easiest steps of them all, because all that we're doing here, we take this annotated AST from the semantics analyzer, and we just produce the source files. So once you have the source files, you're going to run your favorite C compiler like GCC, Clang, Tiny C compiler, or any other compiler that your microcontroller comes with. And just like that, we have, so in 4 phases, we have a tool that can take some source file and produce C code. So lexical analysis, parsing, semantic checks, and then code generation. And just to show you that we are actually saying something that makes sense, I will run a hello world program that, well, it prints hello world because it's hello world. Okay, are you guys ready? Okay. So this is what pinlang looks like. So remember I said you need to be able to use libraries from, or C, what do we call this? To be able to use symbols from C. You want to be able to call functions from C. You want to be able to use variables from C. So what you're seeing there by line number 1 is us importing a C header file. And we're importing the standard input-output header. And then by line number 2, we're importing the s2dlib, which basically allows us to allocate and deallocate memory. So, okay, this is our main function, and it returns an int 32 because every program in C has to return an int. That tells the operating system that the program has executed successfully, not successfully, or whatever, right? So, and then by line number 7 to 8, we're allocating memory at line number 7, and then that memory is where we're going to store the name of the person. And it's that name of the person that we're going to print at line number 17, where we say your name is and your age is. And then by line number 10, we asking the person for their name. And then by line number 13 to 15, we're asking for their age. Then obviously by line number 17, that's where we print it. Line number 19 is where we free the memory that we have allocated here by line number 7. So the first thing we want to do is transpile this source file to C. So that's where the 4 phases now come into play. So pin, main.pin, then you get main.c and main.h. Now, once we have main.c and main.h, we want to be able to produce the executable that we're going to run. So, like I said, you can use any compiler you want. I'm using Clang. So I'm going to run main.c, or I'm going to compile main.c to an executable. That's going to be a.exe. So now if we run a.exe, we expect the program not to crash. Okay. So now it's asking for our name. I want to say this is my name. Just to stress some people here, let's say we are 20 years old. That's our Hello World program. Another thing I want to show you is, so if I do this, right, and then I remove this. So what I want to show you is type inference. So type inference is basically, we can say a variable called A is assigned the number 45. So what you'll notice here is that we didn't specify the type. What that means is that the compiler will infer the type of the variable from this. So which means then it should tell us when the types don't match. Or actually what we can do, let's print the value A. I want to say A is that %d A. Okay, so we're going to rerun the thing from, or recompile everything from scratch. So first we transpile it. Okay, no errors, it transpiled. Then we're going to compile the C header files, or the C source and header files, to produce an executable. That was quick. Then you're going to run the executable. So A is 45, right? So if we want to check the type of A, at this point we can't print the type, but we can actually kind of like see what type the transpiler assigned to A. By doing something like this, I'm going to say 34 as that. Sorry, I can't say 34. I'm going to say 34 as in 64. So now it's going to tell us if we can assign an in64 to whatever type it assigned there. And if it fails, then it's going to print what type it's expecting. So now if I transpile that, by the way, my error logging or my error printing is not that neat yet, but that's something we're still working on. And so what we're seeing is a type mismatch. And what it's saying is that a symbol of type int8 cannot be assigned type int64, which is cool. Because what we have here is an A that is assigned int8, and then here then we try to assign int64, which doesn't make sense. Okay, that's what I wanted to show you. So I will share the link so you'll be able to play around with this, but that's our programming language. That's that. Looks like we're going to have a lot of time for questions. Okay, so that was Hello World. Okay, so we have seen how to design our programming language. That was step one. And we have also seen how to use existing compiler design tools to build a transpiler for our programming language. And that was step two. So the last step, the last and final step, is to share what you have built. Remember that technology is about people. And what you have built does not mean much until other people can actually access it and play with it. Now, depending on your goals, this could mean setting up a website, for example, sharing a post on LinkedIn or Reddit, giving a talk like I'm doing now. Brandon is laughing because I use that picture. Sorry, Brandon. Giving a talk like I'm doing now, and just inviting other people to be part of what is being built. Whatever you do is all up to you, but whatever you do, please do share what you have built. And no, you will not be crazy by sharing what you have built. So I started this journey simply because I was curious. Curious about whether I could make low-level programming feel as expressive and intuitive as the languages I've come to love. And somewhere between writing Legza rules at 2 a.m. and watching my first C code compiled from Pinlang, I realized something. The real power of building your own language isn't in having a tool that works the way you want, but it's in proving to yourself that the gap between I wish this existed and here it is can actually be bridged. Not by waiting for someone else to do it, but by actually rolling up your sleeves and building it. So whether your thing is programming languages, microcontrollers, or something completely different, I hope that my story shows that curiosity paired with persistence can create something that didn't exist before. Because beyond the tools, beyond the code, and beyond the syntax, building something new is about making your ideas real. And you can do that too. My name is Batandwa. I hope you enjoyed the talk. Thank you for listening. Okay, I assume this is where we like. Do you have questions? Okay, do you guys have questions? No questions, thank you. Oh, wow. Do you have a mic?
Is this on? Okay. Hi, thank you. That was very interesting. Something I'm curious about is a large part of modern language design is not just the language itself, but like the tooling that goes along with it. So, for example, when you had VS Code up earlier, you didn't have any kind of language server protocol for Pinlang. Yes. As someone who's obviously built a language now and is sharing it and wants people to use it, how are you planning to like address a package manager, a linter, or any of those other kind of tools that people kind of expect in a modern language?
So, when you go to the Pinlang repo, you're going to see that there's a what do you call it in Markdown? A warning that says please don't use this in production. Right? And that's because it's not ready. So far, I've been experimenting, just playing, and I haven't really used it for any serious projects. And the plan is to have something like that, like a language server, syntax highlighting, VS Code plugin, IntelliJ plugin, and something really cool, which Sia said he's going to work on. I don't know where Sia is now, is a website where you can actually play around with the language without having to install anything. So all of that is still coming, hopefully, but so far this is what we have. So now we have a compiler that can compile some source file, and we can get an executable. But yes, we are looking into things like that.
Cool. Thank you very much.
You're welcome.
Hey.
Hello.
Since I don't know, the inspiration for this language was your what's it called?
Microcontrollers.
Microcontrollers.
Yeah.
Did you end up using this language pin?
Did I end up using it for any microcontrollers?
For the problem you were facing?
No, it's not there yet. So you saw that I did like an import extend stdio.h. That's the C standard input output, right? So to be able to import, let's say, Arduino headers or headers from Raspberry Pi libs, I need to define what's inside those headers. Because at the moment, going back to what Bro asked earlier, I don't have a tool that can look at what's inside headers and pull out the symbols out of those headers so that you can actually access it from pinlang. And so since I can't do that yet, I can't really build anything useful with it in my microcontroller projects. But once I have that tool, I should be able to start doing something like that.
What was this project that you faced this problem with? Like whatever you were using C?
So basically, I was trying to write a program that could measure how voltage changes over time. So basically, I had a pin that had voltage coming in, and that pin, those values that from that pin were then written into an array. And then that array is what then I had to map into millivolts. Then it's that millivolts I had to summarize into a graph. So basically, I wasn't building anything important. I was just trying to see if I can measure how voltage changes over time. So that's what I was working on.
Like my question, my question basically is, when I think about like building something like a new language, is I want to solve a specific problem that I have. And so when you write pin, I'm thinking like you are trying to solve this specific problem. And so I'm just wondering, basically, when you create a side project that is supposed to be useful, where do you, I don't know, draw the line between this is something that is useful or this is something that's just curiosity, basically?
I'm just playing around at this point. Like I said that earlier, I'm just playing around at this point.
Okay.
Yeah.
I think there's a question online first. I'll go next.
Oh, Motero. Hi, Motero. So the first commit, I think, was like 6 months ago, 5 or 6 months ago. So that's round about how long it took to get to where it is now. And obviously, I wasn't working on it like full time, like every day after work, I would go work on it. Sometimes I would take a break for like a week and then I would go back. But I would say around about there, like 4 to 6 months. That's how long it took.
All right. So my question, I loved how you're able to import stuff from like the C library, because I believe you shouldn't reinvent things that already exist, not the problem you're solving. But I would have loved to see the .map functions that exist in JS, because who doesn't love JS? Are you able to import stuff from like JS or other languages as well?
No. So at the moment, making it such that you can import stuff that are in C, because that's what I'm transpiling it to, right? I'm transpiling it to C. So right now, you should be able to import C header files.
Thanks. Oh, last question. I'm guessing it will be, if not a Turing complete language. In future, will you be able to import stuff from other languages?
If we decide to build a JavaScript code generator, then maybe.
Right,
I think it's possible. Because the only thing that for me to be able to produce JavaScript, I just need to modify the code generator or build another code generator that can take this annotated AST and produce JavaScript code. And then the other thing that you have to write is the import parser, which will then take other JavaScript files, pull out the symbols from them, and then allow you to import them into Pinline. But basically,
Thank
those
you
two
so
things.
much.
Those.
Hello. Was there any interesting quirks you found with working with C that you weren't expecting before you started diving into the transpiler?
Any interesting quirks I found while working with C? I don't like the fact that you can cast anything to a void pointer. So I don't know if you guys saw. Actually, so when you go to the repo, there's a folder called regression, and then in that folder you will find this program that I just showed you guys, and you're gonna see that we're casting things to any. The reason why I did that is because C can give you a void pointer, and I needed to be able to represent a void pointer in my programming language. And as of now, I don't want to have pointers, but from the looks of it, I'm supposed to have pointers. And since I didn't want to have pointers, I decided that the void pointer is of type any. And that was interesting because I never planned for void pointers. So that was the interesting part. Okay. Are there any other use cases you'd like to have PN be preferred for in the future outside of microcontrollers? Okay, that's an interesting one. So, okay, I'm sharing my future side projects now. So what I want to do is build like a power bank that has a screen, and then you should be able to interact with that screen. What I'm going to show on the screen, I'm not going to tell you guys, but there should be a screen. So, and so to be able to represent buttons and text box and text and all the other things, I need to write like a tiny, or maybe a wrapper. I'm not sure what's out there already, but I need to write like a tiny GUI library. So I'm thinking this tiny GUI library that I'm going to write could be used outside of just my power bank. So even though it's not the language itself, but the fact that the GUI library is used or is written in that language or in PinLang, it means that PinLang might be able to build apps for Windows, macOS, and Linux to build GUI applications. Something similar to Flutter, but I'm building it for my power bank. But yeah. Any more questions?
Yes, there's a question here. Thanks for the talk, by the way, very interesting. How do you deal with the UTF-16 issue versus ASCII character? I didn't understand how that plays out.
So the plan is not implemented yet, because right now I'm still piggybacking off C's standard library. So the plan is to write like a tiny standard library, if we can call it that, for PinLang, that will implement a string class that can handle the different encodings for characters. So I haven't implemented the standard library yet, so I haven't, so I don't have a class that actually handles the different string encodings. But with what we have built, with with extension methods and char arrays, allows us to say a char array, which is like ASCII characters, can be converted to whatever class we want to convert it to. So that's how I'm actually planning to make the transition from a char array to that string class I will implement be seamless.
Cool, because we need emojis on our power bank.
Yes.
Hello. Okay. I would like to see the Hello World C file. I want to see what the output looks like.
Do you have time, Brett, to show the Hello World C file? It's going to take like 2 minutes. Do you still have
There
time?
might be a few minutes. Well, I can come down afterwards as well, but I'm just curious to see that.
Okay. Should I write like, okay, let's write Hello World. Printf Hello World. Return 0. Okay. Come on. This is Java, by the way, so please. It's still doing its thing. There we go. Okay, so that should give us Hello World. Hello World. Okay, so you want to see the header file and the C source file, right? So if we put that there, you put this one here. Okay, so this part is supposed to be like a tiny, 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 tiny language runtime, but it's still there's work to be done in it. But this is what it looks like. So before, you will see eScript almost everywhere. So before I used to call it eScript, but then I realized eScript basically means electronic script in terms of like doctor's script. So that's why I decided to change the name to Pinlang, but it was eScript for circuits, electronic scripts. Okay. Yes.
Since you are using Java, is the plan to bootstrap this language, or like how does it work with bigger projects? The compilation is very slow.
I see what you're talking about. You mean like when I have like a let's say like 50 source files, for example, 1,000 source files. We're not there yet, but I've been thinking about that, and I'm thinking maybe I can use threads. So
my question basically is, let's say this thing is bootstrapped, right?
you're starting up, or you're
Nay.
compiling it.
The language is written itself.
Okay.
How does the compilation work?
You mean like if we rewrite the language using Pinlang, if we rewrite the transpiler using Pinlang,
Yeah, the whole language, not just the everything.
how will the compilation work?
Yes. Like, do you still compile to C, or
No,
how does it work?
So the requirement I had, or the requirement I still have, is that it has to transpile to C. So even if I choose to use any other language, even itself, maybe in the future, it still has to transpile to C. So the output will always be C.
So then the compilation, if I have some compiler issues or something, if I have 1,000 source files,
Yes.
how long does that take?
Right now,
Once it's been
rewritten. Yeah, I wouldn't know because I haven't done that, right?
Okay.
But maybe we can use threads, and then we can measure how long it takes, right? Because if you have 1,000 source files, you need to find a way to optimize the time.
Guys,
it?
I think time's up. If you
Oh.
want questions, you can see them afterwards.
Cool. Thanks, everyone.